really helpful, and they will help you a lot with graphing. And so what we have here is a transformation of a piecewise function. The piecewise function consists of 1, 2, 3, 4, 5, 6 different lines that have been connected together, and so therefore it's a piecewise function. In transformations, it gets a little difficult when we have more than one operation done at once, such as this equation right here. And so what we're going to do is figure out how to transform this without having to do each one separately in a crazy way. So this one here, table will always help. And so the standard transformation format is always going to be y, and then the a, and then the function. And the function in this case is a piecewise function, so it doesn't have anything specifically. Like if it were quadratic, we would use the square. If it was the square root, it would be the radical. Cube root, same thing. So depending on the function is what your f is. In this case, it just stays off because that's what it's going to be, your graph. And so then we do a bracket, and then it's going to be your b, and then parentheses, and then your x. So standard transformation format will always have a parentheses between the b and the x. And then it's going to be minus c bracket plus d. So this is your standard transformation format. If it doesn't have this parentheses right here, then therefore it is not in standard transformation format. So when we look at the actual graph, if you notice, this one here is missing that parentheses. That means that it is not in standard transformation format, and we actually have to put it in that format. In order to do that, we have to factor out whatever's in front of the x. In that case, it'll turn into a b. And so what it would be -2, and then we keep our f because it's a piecewise function. And then instead of parentheses, I'm going to do bracket and then factor this out, and then it's going to be parentheses. And factoring is the same thing as dividing out. So I could actually just divide this by a -1 and divide that by a -1, and that's the same thing as factoring out. And so what you do here is then you would end up a negative, and a negative is your positive right there, and a negative and a negative is a +3. Sometimes the number will change because b could be greater than 1, and so you would have to factor everything out. And so then we have bracket +1. So this is your standard transformation where your a is going to be -2. Oops, I don't know why I did that. -2. This is your b, which is -1. This is your actual c, and that is your d. So the main thing you need to remember is that in front of the x, you always have to factor. If there is a c, you have to factor out a b. So every single time, otherwise you're going to get the wrong c, and the sign possibly could change as well. So in order to actually follow the transformation, if you notice, I populated the points. These are the ordered pairs of this piecewise function, and I have actually populated them here so that we could do them here and fill them in the table. So in order to do this table, it's kind of difficult to do each one individually, but this makes it a lot easier. There is always an order in which you do them. So it's not in alphabetical order, it's in math order, of course. And so what you do here is you're going to take the b first, and you're always going to start on the inside of the function. And the inside of the function, we go from multiplication. And notice how the inside of the function is the brackets, not the parentheses. And so this here is your b. It's being multiplied, so that goes first. And then the c here is being added, so that goes second. So the c will always be added or subtracted. The b will always be multiplied. So b will always go first. And then c goes second. And then we start on the outside. And so the outside is your a. And so that's because it's being multiplied to the function, and the d is being added. Oops, I wrote that wrong. So this is your a. Oops. So this is your a, and then this is your d. And then their values are always going to be, we're going to write down what we're going to multiply them to. So in this case here, it's your b. So your b is a -1. And your c is always going to be the opposite here. So your c here is going to be a -3. 3, because inside we always do the opposite. And so here's where we're going to use the numbers we're actually going to use to calculate the transformation. So we're going to use those. And so just so you know that if you're going backwards, whatever's in the table is always going to be the opposite when you write the equation. And then your A is always going to be the same as up there, and your D is always going to be the same as well. The only ones that actually change is the B and C, and then your A and D will always remain the same. So inside the function, what happens is that it's always going to be your, the inside is always going to affect your x values. So B and C will always, every single time, affect your x values. And then A and D will always, every time, affect your y values. And what you're going to do is, because B is being multiplied up there, it's going to multiply all your x values. Your C is being added or subtracted out there. So here we're always going to add them to the x values. And then your A is always being multiplied as well. And then your D is always being added or subtracted. So the value you always put here, and then you're going to be able to multiply them or subtract them. So what you do next is that you're going to take these points that are on the actual graph, and you're going to do whatever the transformation asks you to do. So for the first one, if you notice, it's going to be that you're going to leave the 7 alone, because only the x values are going to be multiplied. And that, I skipped the first one. So the 10, and I'm going to leave the 1, and then the 7, and then the negative 4, and then the 4, the negative 4 again, and then the 2. So we always leave the y values alone. They're not going to be affected at all. And then we're just going to change what it is. Since the x values are being multiplied by negative 1, it becomes a positive 10, a positive 8, a positive 5, a positive 2, a positive 1, a negative 1, sorry, it's going to be a negative 1, and then this is a negative 7, and then this is a negative 10. So that's how we would do that. And then what just happened, description and words, is that it's going to be a horizontal reflection over the y-axis, because the x values are changing, so they hop. If the x values are happening, so if I have x values, if they jump from one place to the other, they're going to jump over the y-axis because they're becoming from positive to negative. So that's why we call it a reflection over the y-axis. It's like the x values are jumping over. Then we're going to do this again, but now we're going to subtract 3 from everything, or add a negative 3 to all of them. And so if you notice, again, the y values are not going to be affected. So I just write them over again the same way that they were. So that would be negative 4, and then 4, and then negative 4, and then 2. And now we take from the original. I don't go back to the original because I've already did a reflection over the y-axis. And so now I'm going to do a horizontal shift left 3 units, which means that I keep them in order. I don't go back to the original points and change them. I go from one point to the next point to the next point. So then the next one is going to be 10, and then minus 3, so I get 7, and then 5, and then 2, and then negative 1, negative 4, negative 10, and then negative 13. And so now what has happened is that we've had a horizontal, and horizontal because it's the x-axis. You're moving left and right. And so inside is always the x, so inside will always be horizontal. And so it's a horizontal shift left 3 units. And so that's how you're describing it. You're not saying that you multiplied all the x values by 3 or by -1 and then added a -3. You're describing what's happening to the graph, not what you're doing to the x or y values. And then the next one, what we're going to do is going to be pretty much the same, but this time, now we're done with the x values. So the x values will not change. It's only going to be the y values that are changing. So now we have these values. So I'm just writing them on both spaces because they're not going to change at all anymore. And -10. Okay. And a -13. My computer is, that was a little shaky. Oh well. Okay, so now what we're going to do is we're going to do the same thing that we did before, but now to the y's. So now we're going to multiply the y's by a -2, because that's the first thing we're going to do. I'm going to change that into a different color. And so we're going to do now -20, -2, -14, 8, -8, 8, and -4. So now we have the new y values. And so notice how the x values didn't change. And now we're going to do the same thing. But now before we do that, let's do a description of what's happening to the graph. So the graph, because it's a y value, it's going to be vertical. So this one here is going to be a vertical stretch because I multiplied all the y values by 2. That means the y values got bigger. That means that it has been stretched by a factor of 2. And because it's negative, all the y values that were positive became negative, and all the negative y values became positive. So again, they went from down here to up here. So now they're jumping the x-axis. So we call this a vertical reflection over the x-axis. So one thing that you need to know, because b is being multiplied, that's going to be possibility of the stretch or shrink. And also a reflection. So B could have two possibilities, same as A, because it's being multiplied. It has the possibilities of two things as well. C and D only have one. They either move left or right or up and down. So A and B have two things that could happen depending on if the value is negative or if the value is 1. So that's why this one here only had 1, because it was a value of -1, and this one had 2 because it was a negative and a number. So when we get to D, we're going to do the exact same thing again, but this time we're going to add 1 to everything, and so it's a positive 1, so we get -19, we get -1, -13, 9, -7, 9, and -3. And so what happened here is that there was a vertical, and we're describing it because it's the y values that got affected. So anytime it says vertical, you know it's y. Anytime it says horizontal, you know it's the x values that it's talking about. So this one here, this one. And so here's a quick thing that we need to talk about is that it was a vertical shift up 1 unit. And so we finished all the points, and all the transformations have been, we have horizontally reflected it over the y-axis, horizontally shifted it left 3 units, vertically shifted and stretched it and reflected it over the y-axis. So everything has been done already to all the points in order. And so now we went back up here and we plotted them. And so we plotted it where it was each one and then connected the lines. And so here's a graph with everything that's there. So this is your graph of g of x. Your original was your f of x. So the black one was your f of x. The blue one is now your g of x with all the transformations happening on it. And so a couple of things you need to remember is that the B has two operations that could happen. The A has two operations that could happen because it's multiplication. And the B and C are always inside the function and they're always going to be horizontal. And then because they're dealing with the X values, and A and D are dealing with the Y values, so it's always going to be a vertical stretch, shrink, or shift down there. And so that's what it actually looks like, and that's what a transformation all in one step would be able to do. And so you know that that you're done when you have all the last points plotted and changed. And then here's a couple of things that we wanted to talk about. Just in case here, I'll do it all over again. Oops. And so we'll erase that. And so if we look, what happened here was that the B is a little bit different. And so if we look here, this is not in standard transformation format. And the reason why it's not in standard transformation format is because there's no parentheses in between the X and the B. If there is a C, you always have to factor out a B. So only if there's a C does it need a parentheses, otherwise it's fine. But if there's a C, you have to factor out a B. And so this one here is 1/2. So the B is 1/2. And so we know that anytime that we're dealing inside of parentheses, it's always going to be the opposite. I know with C is that if it's supposed to go left, it goes right, and if it goes right, it's supposed to go left, and so on. But with the B, it's the different. So if B is supposed to shrink, it actually stretches, and if it actually is supposed to stretch, it actually shrinks. And by that I mean that I'm going to take the B, which is 1/2, and the B is going to multiply all the X values by 1/2. If that happens, then all the X values will become smaller. So in essence, it's supposed to shrink, compress. So, but because it's in the opposite, we can't have it do that. It always is going to do the opposite. So therefore, it has to stretch. And so it's going to be a horizontal stretch, but it's still, the 1/2 is only making them smaller. So what you have to remember is that B, and this is true every single time, is that B will always be the reciprocal. So in this case here, it's 1/2, but we need to do the reciprocal. And so the reciprocal of it is actually 2, and therefore that's what's going to make it stretch. What we're going to do is we're going to take the B, and in the table you always want to put what you're going to either multiply or add to the X or Y's. So in this case here, you're going to put in that it is 2. Even though the B is actually 1/2, whenever you look at a table in the equation, you do the opposite. From the table, from the equation to the table, you always do the opposite. So that means that every value of the X values are going to be multiplied by 2, which that means they're going to make them bigger, which means that they're going to stretch. And so once you're done with that, then we are good. But in order to actually factor out a B, and that's what we were talking about, is that instead of when we factor out a B, what's going to happen is that you are going to divide this by 1/2. So if I divide this by 1/2 and I divide this by 1/2, that's kind of a little messy. So we know that we want to have, it's going to be negative, and then you're going to have the bracket, and then the 1/2, we're going to put it on the outside, but on the inside that gives you the 1, and so that's going to be X. But the 2 divided by 1/2, in order to do this is the same thing as having a fraction divided by a fraction, because the 2 could also be written as a fraction by putting it over 1. And anytime you have a fraction divided by a fraction, it's always going to be that you do multiplication instead of division, and we always do the reciprocal. And so when you multiply that, you end up getting that to be 4. Notice how the C has now changed from a 2 to a 4, and the B has stayed the same. So the only one that's going to be affected if you don't factor it out and put it in standard form is the C, and you don't want to lose points from that. And so that's what it will be. And so if it is stretching, then of course it would be something similar to, like, say, for instance, that it would be F, and then it would be 2, and then X plus 2, let's say. That means that it's supposed to stretch, but it's always the opposite, so we need it to shrink. So the 2 gets converted to a 1/2 by the same reason, but it's easy. That's what it's going to be to multiply. That's what we would put in here, and then the 2, you would just divide that by 2 and divide this by 2. And so when you put it in the table, it becomes 1/2. It is the reciprocal, so that it actually will shrink. That's it. That it's not a piecewise function. That my actual f in the y equals to a f of b x minus c plus d, that this f is actually my quadratic. So let's just assume that that's the case. If it is my quadratic, then how do I find the points if I don't have a graph? Well, we actually do. And what you're going to do is you're going to go to the parent function where there's nothing been added, multiplied, or anything. So it's just the x squared, because what this is a quadratic. That's what your f is a quadratic. It's a quadratic, and so therefore we're going to get the original points from just the basic parabola. So when we look at it, and if we were to graph it, we would choose points around the origin, and so this point would be, let's say, the x value of -2, and so when I plug -2 in here, I get 4, and then when I put in -1, let's say, then I get 1, I square it, and then 0, 0, and it says 5 points. So what we're going to do then is going to go 1, 1, and then 2, 2. So those are the points that I choose instead of a piecewise function, which I just take the points off of it and plot them. If I am given a function, I take the parent function and then I find the points. And then I do the exact same thing that I did before, and then I graph it. I know that the parent function is actually just a regular parabola. I would plot those points. Actually, I guess we could plot the points nicely. And so the parent function points are going to be -2, and then 1, 2, 3, 4, 2, 1, 0, 0, and then they're going to be mirror image. So this is your parent function, the parabola. And so those are how you get the points, and then you do it everything the same way that we've done before, where this is going to be your B, C, D, B, C, A, and D. I was doing the alphabet there for a minute. And so that would be it. So that's the only difference. And then here, if I want it, it's not in standard transformation format. So what you would have to do is actually put it into standard transformation format. And so remember, there has to be a parentheses there. And so there has to be a parentheses there. So that means I have to factor out a 1/4 and a 1/4 from there. So what it actually would be, the transformation format would be, if we filled it out right below it, it would be y equals, my a is still -3, my f is the quadratic, so I don't need the f anymore, and then bracket, and then the b is still going to be 1/4 parentheses x, because they cancel out and become 1, and then 1 divided by 1/4 is the same thing as 1 times 4/1, so that ends up being +4, and then -5. So notice how the f is gone because it's replaced by this quadratic right here. That is your f, so that 2 telling you what type of function it is. It's not a piecewise function, it's a quadratic, so the 2 tells you that's your f. And then you have your a, your b, your c, and your d. And then that's it. And then you do everything the same way.